Now we formally start wrapping up the simulation model, because now we have all the details we need regarding our simulation model. But since it is the third simulation model that we are doing, we are going to do it in a more advanced way without covering details like the previous one, the way we did it. So after this slide, we quickly start doing the model uh, under an activity, under the cover of an activity. Okay, so when we want to do the model, we have these main parts that you can see, and each part is a column in the Excel file that we are gonna create. So one column is the number of runs, or the each run is a month that we are gonna do it until number 1000. In fact, we are gonna do this simulation for 1000 months, and we have another thing that is Q, like the previous simulations that we have had so far. Always there are some parameters, but it is a decision variable that they are fixed, so we will put it in the first column. After that, we have the demand. If I want to show you what was the demand, here we have all the description, I guess. Okay, where is the demand? As you can see here, the monthly demand for the router is described by a normal probability. Here, let me show you this way. Okay, here we have monthly demand for the router is described by a normal probability distribution with a mean of 100 units and a standard deviation of 20 units. So when we have this description of mean 100 and a standard deviation of 20 units, means that we can handle that column easily. So about the demand, normal distribution of mean 100 and standard deviation of 20. Gross profit, you know how to calculate it. Holding cost, you know. Shortage cost, you know. And net profit is the result of these three things. And we only need to talk about the service level, that I'm gonna talk about this while we are doing the simulation model. So in that way, you can stay caught up much better. So in the next slide, that is activity 1, it's just in one activity asked us to run a 1000 month simulation model if Q equal to 100. So in the following slides, no, in the this video follows with Excel description of this simulation model. But my suggestion is that stop your video here and try to develop your own simulation model. Just in case of problem and not knowing what to do, check the video. And in that way, you are gonna practice it in much better, because now you know everything about it except the service level that we are gonna talk about it more. You see in front of you now the raw structure, the empty structure for doing the simulation project, and it is in basic points very similar to the previous one. On the first column we have the simulation numbers, and Q, demand, gross profit, holding cost, shortage cost, and finally net profit. So we are gonna fill out all these columns and to calculate net profit, and after that we are gonna do the average, and also remember we have to calculate the service level as well. Okay, so as you noticed in activity 1, it says do the simulation if Q equals to 100. So we put 100 here, and we double click, we populate it like this. Of course, there are other ways to do these things. For example, you can define Q in some other cells and get these cells values from that cell. I don't want to make it that much sophisticated. It is not, all of them are very easy. I just mean that the focus here is on the simulation model. But if you like to make your model fancier, more sophisticated, feel comfortable to do any of those things. I'm just doing it as simple as possible. The next things that we are going to do is doing the demand. Demand is normal, so we are going to do a random normal number, and here I put rand, and you can see all the formula, everything, and mean is 100 and standard deviation was 20. So now we have random number. No need to freeze the numbers and just populate it like this. So it is the demand in each month that now we have them calculated, generated. Now here we try to populate the columns of gross profit. And okay, to calculate the gross profit, we know that the gross profit per each router is 50. But here, to calculate it, we must specify that the number of items that being sold according to these two columns that we have here, Q and D. So we need to put this formula, as you can see it here, if, because if Q is greater than demand, so what would be the gross profit? Because Q is greater than demand. So how many items they are gonna sell, or they are selling when Q is greater than demand? They are gonna sell demand. That is D3. So if Q greater than demand, they are gonna put D3 times 50. So D3 times 50. Why? Because Q is greater than demand, and demand is the number of items being sold. So the number of items being sold is D3 times 50, that each of them, that each gross profit per unit. But otherwise, so if demand is greater than Q, so they are gonna sell Q routers. So it would be C3 times 50. And so we have the formula like this. And I'm gonna populate it. Let's see, to check if you have done it right or not. There are some rows that shows the gross profit is 5,000, fixed number. Okay, although it is random numbers, yes, but it's 5,000. These are the cases that demand is greater than Q. And since demand is greater than Q, demand is not the determining factor in gross income. Since demand is greater than Q, Q is the determining factor. And since Q is 100 times 50, 5,000 would be the fixed gross income that we have here. So if we check those rows with this fixed 5,000 gross profit, in those cases, in all of them, demand is greater than Q. So now let's check it. Here we have the first one. You see demand is greater than Q. For this one, demand is greater than Q. For this one, again, demand for greater than Q. But for this one, you see demand is smaller than Q. So demand is the determining factor for gross profit. And remember, my friend, you can do these columns in many other ways, and I'm doing them in the simplest way possible. So if you like to do them in another way, for example, in one column you check which one is greater, Q or demand, and after that assign it to your gross profit column for fancier type of spreadsheet, feel comfortable to do that, and kudos for your determination in doing this job better. And the next item that we are going to do is holding cost. Remember, holding cost would be 0 if there is no inventory cost at the end. So inventory, we have this column just in case that we have inventory cost. When we have inventory cost, we have inventory cost when Q is greater than demand. When Q is greater than demand, it means that at the end of this period, we have some inventory and we need to pay for that. And now with the formula that I'm going to put here, you will understand the point better. Here you see the formula that we have for the holding cost here. Again, to have holding cost, Q must be greater than demand. Otherwise, it would be 0. So that's the reason. First, you see if clause, as you can see here, if C3 is greater than D3. C3 is Q and D3 is demand. So it says if Q is greater than demand, okay, we are going to have some inventory cost. How much you are going to pay for each inventory that you have at the end of the period? $15 according to the case description. So if Q is greater than demand 15 times, okay, how many routers do we have at the end of the period? It would be Q C3 minus D3 demand, because at the beginning of the period you had C3 and you sold D3 of them, so you are going to pay C3 minus D3 times 15 at the end of the period. So here we have the holding cost, and if I populate this one, okay, again another thing happens here. You see with some rows we have fixed number of 0, and okay, that 0 rows are the rows that no holding cost happen, because the Q that is the inventory at the beginning of the period is smaller than the demand. So since the demand is greater than Q, so all the inventory would be sold out and we would have 0 inventory at the end of the period. So in that situation, the holding cost would be 0. So if we go and check the demand and Q for those rows with 0 inventory, we notice that D would be greater than Q. Let's check it together and see. For example, here we have holding cost of 0, and here you see demand is 110 and Q is 100. For the next one, again, the demand is greater than 100, so the holding cost would be 0, and like that it continues. But for the other ones that we have holding cost, of course the demand is smaller than Q. As you can see, it is, for example, 70. Okay, as the next one, we are gonna do the shortage cost. Shortage cost is very similar to the holding cost, and you will see the formula and population soon. Now you see the formula for shortage cost that is very similar to holding cost with the trivial differences. It says again, check, because shortage cost happens only if demand is greater than Q. So the first thing that it checks is that if C3, that is Q, is smaller than D3, that is demand. So if C3 is smaller than that, just check the differences between them, that is D3 demand minus C3, that is Q, times 30, that is the cost of shortage per each router, and otherwise it would be 0. And now if I populate it, we come up with these things. Again, the same thing, you will find some of the rows 0 that are pertain to the situation in which the Q is greater than demand. If we check it, you will notice, for example, here Q is greater than demand.